This image is one of the most iconic of all Hubble images.
There's so much concern that there's something locked up, classified.
NASA's latest discovery has everyone talking, from scientists to religious leaders around the world. Researchers have found new evidence about how the universe is structured and where it all began, making us question some of the beliefs we've held for a long time about how the cosmos was created and what it means for us. So what does this all mean? How will this reshape our understanding of the universe? And what about the delicate balance between science and faith? Join us as we uncover NASA's terrifying new discovery that shocks all religious people. Hubble Space Telescope's journey and discoveries. The Hubble Space Telescope has been a crucial tool for astronomers since its launch on April 24, 1990. Carried into orbit by the Space Shuttle Discovery, Hubble has dramatically changed our understanding of the universe through its breathtaking images. However, the telescope's journey wasn't without challenges. Shortly after its deployment, NASA discovered a significant flaw in Hubble's primary mirror. This defect resulted in blurry, unfocused images, which was a major setback for the mission. Despite this initial problem, Hubble continued to capture images of nearby planets and distant galaxies, providing valuable data to astronomers. The real turning point came in December 1993, when NASA sent a team of space mechanics on a repair mission. They equipped Hubble with new instruments and made adjustments to correct the mirror issue. This intervention proved successful, and the quality of Hubble's images improved dramatically. With its enhanced capabilities, Hubble began to reveal previously unseen aspects of the cosmos. It allowed scientists to peer into remote corners of the universe, capturing light from distant galaxies and providing new insights into the nature of space. One of Hubble's most famous images is the Pillars of Creation, a striking view of star-forming regions in the Eagle Nebula. This image, along with many others, has not only advanced scientific understanding, but also captured the public's imagination, bringing the wonders of space to a wider audience. The telescope's longevity is remarkable. Originally designed for a 15-year mission, Hubble has far exceeded expectations and continues to operate over 3 decades after its launch. Regular servicing missions and upgrades have kept it at the forefront of astronomical research. Hubble's success paved the way for future space telescopes, including the James Webb Space Telescope, which builds on Hubble's legacy with even more advanced technology. Throughout its mission, Hubble has captured over 1.5 million observations of the universe. Its data has been used in thousands of scientific papers, making it one of the most productive scientific instruments ever built. From studying nearby planets in our solar system to observing galaxies billions of light years away, Hubble has truly transformed our view of the cosmos, the hand of God, celestial formation. In the vast expanse of space, astronomers have discovered a celestial formation that bears a striking resemblance to a human hand. This cosmic structure, dubbed the Hand of God, offers a fascinating glimpse into the dramatic aftermath of a star's death. The image was captured by NASA's Nuclear Spectroscopic Telescope Array telescope, which specializes in detecting high-energy X-rays. This unique perspective allows scientists to observe phenomena that are invisible to optical telescopes. The Hand of God is a pulsar wind nebula formed by the remnants of a massive star that exploded in a supernova. At the center of this formation lies a dense, rapidly spinning core called a pulsar. This pulsar, known as PSR B150958, rotates at an astonishing rate of 7 times per second. As the pulsar spins, it generates a powerful wind of particles. These particles interact with the surrounding magnetic fields, creating the distinct hand-like shape we observe. The energy involved in this process is immense, producing X-rays that NuSTAR can detect. The structure's appearance as a hand is an example of pareidolia, a psychological phenomenon where humans tend to see familiar patterns in random shapes. While it may look like a hand to us, it's important to remember that this is a natural formation shaped by intense cosmic forces. The fingers of the hand are composed of high-energy particles being ejected from the pulsar. The palm area is where these particles collide with gas in the nebula, causing it to heat up and glow in X-ray light. Interestingly, the Chandra X-ray Observatory had previously observed the same structure at lower energy levels. The combination of data from both NuSTAR and Chandra provides a more complete picture of the complex processes at work in this nebula. Near the fingertips of the hand is a red cloud known as RCW89. This cloud is believed to be heated by the pulsar's winds, causing it to emit a soft X-ray glow. The energies observed in this region range from 7 to 25 keV in NuSTAR's observations and from 0.5 to 2 keV in Chandra's. The study of such formations helps scientists understand the life cycles of stars and the processes that occur after a supernova. It provides insights into how pulsars interact with their surroundings and how they distribute energy and matter into space. As our ability to observe the universe in different wavelengths improves, we can expect to uncover more such fascinating formations, each offering new clues about the physical processes that shape our cosmos. Mars's ancient watery past and potential for life. Mars, often called the Red Planet, has long fascinated scientists and space enthusiasts. Recent studies have revealed compelling evidence that Mars once had a much more hospitable environment, potentially capable of supporting life. The planet's southern highlands, particularly near the Hellas Basin and around Huygens Crater, display intricate networks of valleys. These formations strongly suggest the presence of flowing water in Mars' distant past, approximately 3.5 to 4 billion years ago. The valley systems bear a striking resemblance to river networks on Earth, such as the Yarlung-Shangpo River, indicating a similar formation process. Geological evidence points to water flow from north to south, carving out impressive valleys up to 2 kilometers wide and 200 meters deep. Over time, these valleys have eroded, but their remnants still tell the story of Mars' watery history. The scale and distribution of these features suggests that Mars once had a much thicker atmosphere, capable of maintaining liquid water on its surface for extended periods. The presence of water is crucial for life as we know it, making these findings particularly exciting for astrobiologists. While the current Martian surface is inhospitable, with its thin atmosphere and extreme cold, the planet's past conditions may have been conducive to microbial life. Various sources likely contributed to Mars's ancient water systems. Besides possible rainfall and rivers, scientists speculate that groundwater and melting glaciers may have played significant roles in shaping the Martian landscape. To further investigate Mars' potential for past or present life, space agencies are planning ambitious missions. The ExoMars mission, a collaboration between the European Space Agency and Roscosmos, aims to send a rover to Mars to search for signs of life beneath the surface. This mission will be complemented by the ExoMars Trace Gas Orbiter, which will study the Martian atmosphere from above. These missions are part of a broader strategy to explore Mars comprehensively. Future plans may even include bringing Martian samples back to Earth for detailed analysis, a feat that would significantly advance our understanding of the planet's history and potential for life. The study of Mars's watery past is not just about understanding one planet. It provides valuable insights into planetary evolution and the conditions necessary for life to emerge and thrive. By comparing Mars's history with Earth's, scientists can better understand the factors that make a planet habitable and how these conditions can change over time. First observation of a polar cyclone on Uranus. NASA scientists have made a groundbreaking discovery on Uranus, observing a polar cyclone at its north pole for the first time. This finding adds Uranus to the list of planets in our solar system known to have such atmospheric features, furthering our understanding of planetary weather patterns. The discovery was made through the analysis of radio waves emitted by the planet. This method allowed scientists to detect atmospheric characteristics that are not visible through traditional optical observations. The polar cyclone on Uranus is characterized by a warm, dry core that remains stationary at the pole, unlike Earth's hurricanes which move across oceans. Uranus, the seventh planet from the Sun, is known for its tilted axis, which causes extreme seasonal changes. Its 84-year orbit around the Sun means that its poles are exposed to sunlight for decades at a time, followed by equally long periods of darkness. This unique orbital characteristic makes the observation of its poles particularly interesting to scientists. The Very Large Array in New Mexico played a crucial role in this discovery. Observations made in 2015, 2021, and 2022 revealed that Uranus's north pole was warmer and drier than expected, indicating the presence of a large cyclone. This finding challenges previous assumptions about Uranus's atmosphere and highlights the dynamic nature of gas giant planets. Comparisons have been drawn between this cyclone and similar features observed on Saturn by NASA's Cassini mission. These similarities provide valuable data for understanding the formation and behavior of such storms on different planets. One of the most intriguing aspects of this discovery is the cyclone's stability. Unlike Earth's hurricanes, which dissipate after making landfall, the polar cyclone on Uranus appears to be a long-lasting feature. This permanence raises questions about the energy sources and atmospheric dynamics that sustain such massive storms on gas giants. The timing of this discovery is particularly fortunate. Uranus is currently positioned in its orbit in a way that allows Earth-based telescopes to observe its poles clearly for the first time in decades. This alignment provides a rare opportunity for scientists to study these regions in detail. This new information about Uranus's atmosphere contributes to our broader understanding of planetary science. By comparing atmospheric phenomena across different planets, scientists can develop more comprehensive models of how planetary atmospheres function and evolve. The discovery of the polar cyclone on Uranus opens up new avenues for research. Future studies may focus on understanding the cyclone's internal structure, its interaction with Uranus's magnetic field, and its role in the planet's overall atmospheric circulation. As our technology and observational techniques continue to improve, we can expect more discoveries not only to enhance our knowledge of these distant worlds, but also to provide valuable insights into the diversity and complexity of planetary systems in general. Decoding the sun's mysterious heartbeat signals. Scientists have made a significant breakthrough in understanding mysterious signals emanating from the sun during solar flares. These signals, known as quasi-periodic pulsations, resemble heartbeats when graphed and could revolutionize our comprehension of solar storms. Solar flares are intense bursts of radiation from the sun's surface that release various types of energy, including radio waves, microwaves, and ultraviolet light. These flares are often accompanied by coronal mass ejections, massive eruptions of solar material into space. The QPPs have long puzzled researchers who struggled to pinpoint their origin and significance. However, a study published in Nature Communications on December 12, 2022, has shed new light on these enigmatic pulses. The research team analyzed data from a medium C-class flare that occurred on July 13, 2017, revealing not one but two distinct pulsation patterns. The primary pulse, occurring every 10 to 20 seconds, originated from the base of the current sheet, a region where magnetic field lines break and reconnect during a solar flare. A secondary, softer pulse with a 30 to 60-second interval was observed across the entire current sheet. This discovery challenges previous theories about solar flare dynamics and energy release mechanisms. The researchers believe that both pulse patterns likely stem from the formation of magnetic islands within the current sheet. These islands are areas where magnetic field lines twist and reconnect, playing a crucial role in the energy release process during solar flares. Understanding these pulsations is key to predicting and potentially mitigating the effects of solar storms on Earth. Solar flares and CMEs can disrupt satellite communications, affect power grids, and pose risks to astronauts in space. By decoding the sun's heartbeat, scientists may develop better early warning systems for these events. The research team's findings also open up new avenues for studying the sun's magnetic behavior. By analyzing these pulses, scientists can gain insights into the complex processes occurring in the sun's atmosphere during flares, which are difficult to observe directly due to the intense heat and radiation involved. Moreover, this discovery may have implications for our understanding of other stars. If similar pulsations can be detected in distant stars, it could provide valuable information about their flare activity and magnetic properties. The study of QPPs also highlights the importance of long-term solar observation programs. The ability to detect and analyze these subtle signals relies on continuous, high-resolution monitoring of the sun across multiple wavelengths. As solar activity continues to increase towards the peak of the current solar cycle, expected around 2025, these findings will be crucial for predicting and understanding solar weather phenomena. The sun's cosmic heartbeats may hold the key to unlocking many mysteries about our star's behavior and its impact on our technological society. The pillars of creation in the Eagle Nebula. The pillars of creation, located in the heart of the Eagle Nebula, M16, are one of the most iconic and awe-inspiring structures captured by the Hubble Space Telescope. These towering columns of cosmic dust and gas have captivated scientists and the public since their discovery. Spanning about 4 to 5 light-years in length, these pillars are a small part of the much larger Eagle Nebula, which measures approximately 70 by 55 light-years. The nebula, first discovered in 1745 by Swiss astronomer Jean-Philippe Louis de Chezot, lies about 7,000 light-years away in the constellation Serpens. The pillars of creation are more than just a visually striking formation. They serve as an active stellar nursery. New stars are forming within these dense clouds of gas and dust, hidden from direct view. The star formation process within these pillars provides astronomers with valuable insights into the life cycle of stars and the evolution of galaxies. The colors visible in Hubble's image of the pillars are not just for aesthetic appeal. They convey important scientific information. The bright blue areas indicate the presence of oxygen, while the rich reds represent sulfur. The vibrant greens are a combination of both nitrogen and hydrogen. These color variations help astronomers understand the chemical composition and physical conditions within the nebula. One of the most fascinating aspects of the pillars is their dynamic nature. They are constantly being shaped and eroded by the intense ultraviolet light from nearby young, hot stars. This process, known as photoevaporation, gradually sculpts the pillars, potentially leading to the exposure of the newly forming stars within. The latest Hubble image of the pillars, captured in 2014, provides the clearest view yet of this cosmic structure. The increased detail and clarity in this image allow scientists to study the fine structures within the pillars, providing new insights into the processes of star formation and the interaction between stellar radiation and interstellar matter. Observing the pillars of creation from Earth requires specific conditions and equipment. While the Eagle Nebula itself can be seen with a small telescope, particularly in July when viewing conditions are optimal, the pillars themselves are only visible with larger, more powerful telescopes. The study of the pillars of creation extends beyond just understanding this particular structure. It provides crucial data for modeling star formation processes throughout the universe. By observing how stars form and interact with their surrounding environment in the pillars, astronomers can better understand similar processes occurring in distant galaxies. As our observational capabilities continue to improve, structures like the pillars of creation will likely reveal even more secrets about the cosmic processes that shape our universe. They stand as a testament to the ongoing drama of stellar birth and death, playing out across the cosmos, offering a glimpse into the dynamic and ever-changing nature of our galaxy. Me87. Me87, also known as Messier 87, is a remarkable elliptical galaxy that stands out as a true cosmic powerhouse. Located approximately 54 million light-years away in the constellation Virgo, M87 is a central figure in the Virgo cluster, a massive grouping of about 2,000 galaxies. What sets M87 apart is its sheer scale and the extraordinary features it possesses. Unlike our Milky Way, which contains several hundred billion stars, M87 boasts several trillion stars. This enormous stellar population makes M87 one of the most massive galaxies in our local universe. At the heart of M87 lies a supermassive black hole, which gained fame in 2019 when the Event Horizon Telescope captured the first ever image of a black hole's shadow. This black hole is estimated to have a mass of about 6.5 billion times that of our Sun, making it one of the most massive known black holes in the universe. Another distinguishing feature of M87 is its unusually large population of globular clusters. While our Milky Way has about 150 of these ancient, spherical collections of stars, M87 hosts an astounding 15,000 globular clusters. This wealth of globular clusters provides astronomers with valuable information about the galaxy's formation history and evolution. M87's unique characteristics extend beyond its core. One of its most striking features is a relativistic jet of plasma that extends from the galaxy's center. This jet, visible in multiple wavelengths of light, stretches for thousands of light years, and is propelled by the energy from the central black hole. The jet's blue color in visible light images is due to synchrotron radiation, produced by electrons moving at nearly the speed of light. The galaxy's position at the center of the Virgo cluster has likely influenced its evolution. Scientists believe that M87 has grown over time by absorbing smaller galaxies, a process that may explain its large number of globular clusters and its enormous size. First discovered by Charles Messier in 1781, M87 continues to be a subject of intense study. Its apparent magnitude of 9.6 means it can be observed with a small telescope under good conditions, particularly in May, when viewing is optimal. Recent observations by the Hubble Space Telescope have provided stunning images of M87 in both visible and infrared light. These images reveal the galaxy's elliptical shape and the prominent jet emanating from its core, offering astronomers new insights into the structure and dynamics of this cosmic giant. The study of M87 is crucial for understanding the formation and evolution of massive galaxies, the behavior of supermassive black holes, and the dynamics of galaxy clusters. As our observational techniques and technologies continue to advance, M87 will likely continue to reveal new secrets about the nature of our universe and the extreme environments that exist within it. Curiosity rover's findings in Gale Crater on Mars. NASA's Curiosity rover, launched in 2011, has been exploring Mars's Gale Crater since 2012, providing invaluable insights into the red planet's past. Under the leadership of project scientist Ashwin Vasavada, the mission has focused on unraveling the mysteries of this particular Martian region. Gale Crater, formed about 3.5 billion years ago, offers a unique window into Mars' geological history. The primary question driving Curiosity's mission is whether this area could have supported microbial life in the distant past. During this period, Mars likely had a much thicker atmosphere and abundant liquid water, creating conditions potentially favorable for life as we know it. Curiosity's mission goes beyond searching for actual life forms. Instead, it aims to identify the basic requirements that would have made life possible. These include the presence of liquid water, carbon, and other essential chemical elements, as well as potential energy sources that primitive microorganisms could have utilized. In its first year of exploration, Curiosity made a significant discovery at Yellowknife Bay. This site revealed evidence of an ancient lake bed, providing crucial information about Mars' past environment. The chemical analysis of this area showed that it was neither too acidic nor too salty, making it potentially habitable for microbial life. Further investigations uncovered the presence of key elements necessary for life: carbon, nitrogen, sulfur, and phosphorus. Additionally, Curiosity detected potential energy sources that could have supported microbial metabolism. These findings collectively suggest that ancient Mars, particularly in the Gale Crater region, might have had conditions suitable for supporting primitive life forms. The rover's ability to analyze the chemical composition of Martian rocks and soil has been crucial in piecing together the planet's environmental history. By studying the layers of sediment in Gale Crater, scientists can reconstruct how the Martian environment changed over time, potentially revealing periods when the planet was most hospitable to life. Curiosity's findings have implications beyond Mars. They contribute to our understanding of planetary habitability in general, helping scientists refine their search for potentially life-supporting environments on other worlds in our solar system and beyond. The mission has also provided valuable data on Mars' current environment. By monitoring radiation levels, atmospheric composition, and weather patterns, Curiosity helps scientists assess the challenges future human explorers might face on Mars. As Curiosity continues its journey up Mount Sharp, the central peak within Gale Crater, it is potentially bringing us closer to answering the fundamental question: did life ever exist on Mars? Discovery of Earth-sized exoplanet, Kepler-186f. NASA's Kepler Space Telescope made a groundbreaking discovery with the identification of Kepler-186f, the first Earth-sized planet found within the habitable zone of its star. This finding marks a significant milestone in the search for potentially life-supporting worlds beyond our solar system. Kepler-186f orbits a star known as Kepler-186, which is classified as an M dwarf or red dwarf. These stars are the most common type in our galaxy, making up about 70% of the stars in the Milky Way. The planet is located approximately 500 light-years away in the constellation Cygnus. What makes Kepler 186f particularly interesting is its position within its star's habitable zone. This region, often called the Goldilocks zone, is where conditions might allow for the existence of liquid water on a planet's surface, a key ingredient for life as we know it. While previous exoplanet discoveries had identified larger planets in the habitable zone, Kepler 186f is the first to match Earth's size closely. The planet completes an orbit around its star every 130 days, receiving about 1/3 of the energy from its star that Earth gets from the Sun. This places Kepler 186f towards the outer edge of the habitable zone, suggesting it might be more like Mars in terms of the energy it receives. Despite its Earth-like size, there's still much we don't know about Kepler 186f. Its mass and composition remain uncertain, though based on its size, scientists suspect it's likely to have a rocky surface. The planet's atmosphere, if it has one, is also unknown. These factors are crucial in determining whether the planet could support life. The discovery of Kepler 186f is part of a broader effort to find and characterize potentially habitable worlds. It demonstrates that Earth-sized planets in habitable zones of other stars do exist, boosting optimism about finding other potentially life-supporting planets. This finding has important implications for future space missions. NASA's Transiting Exoplanet Survey Satellite and the James Webb Space Telescope are designed to build on discoveries like Kepler 186f. These missions aim to find more Earth-sized exoplanets and study their atmospheres, potentially detecting signs of life. The study of exoplanets like Kepler 186f also helps us understand the diversity of planetary systems in our galaxy. By comparing these distant worlds to planets in our solar system, scientists can gain insights into planetary formation and evolution processes. While Kepler 186f represents an exciting discovery, it's important to note that being in the habitable zone doesn't guarantee a planet's ability to support life. Many other factors, such as planetary magnetic fields, atmospheric composition, and geological activity, play crucial roles in a planet's potential habitability. Titan's methane lakes and seas, a unique hydrological cycle. Titan, Saturn's largest moon, has captured scientists' attention with its unique surface features that mirror Earth's hydrological systems. Unlike Earth's water-based cycle, Titan boasts lakes and seas composed of liquid methane and ethane, creating a fascinating alien landscape. NASA's Cassini spacecraft, which studied the Saturn system from 2004 to 2017, provided groundbreaking data about Titan's surface. The discovery of liquid bodies on Titan's surface in 2007 marked a significant milestone in planetary science, as it's the only world besides Earth known to have stable liquid on its surface. Recent studies have revealed surprising complexities in Titan's lake systems. The Moon's northern hemisphere features deep lakes nestled on hills and mesas, primarily filled with methane. This contrasts with the mixed methane-ethane composition found in Titan's larger seas and in the southern hemisphere's Ontario Lacus. The distribution of these liquid bodies is not uniform across Titan's surface. The eastern part of the northern hemisphere hosts the largest seas, while the western side is dotted with smaller, deep lakes perched atop elevated terrains. Some of these lakes plunge to depths of over 300 feet, showcasing the diverse topography of Titan's surface. Scientists believe these lakes may have formed through a process similar to karstic lakes on Earth, where the surrounding bedrock dissolves and collapses. On Titan, this process would involve the chemical dissolution of the ice and organic bedrock by liquid methane, creating depressions that fill with liquid. One of the most intriguing aspects of Titan's hydrological system is the presence of transient lakes. These bodies of liquid appear to undergo seasonal changes in their levels, possibly due to evaporation or seepage into the subsurface. This phenomenon suggests a complete methane-ethane cycle on Titan, analogous to Earth's water cycle. The temperature on Titan's surface is so cold that water exists as rock-hard ice. In this frigid environment, methane and ethane take on the role that water plays on Earth, existing in liquid, solid, and gaseous states. The study of Titan's lakes and seas extends beyond mere curiosity. It provides valuable insights into the potential for life in extreme conditions. While life as we know it couldn't survive in Titan's methane lakes, the presence of complex organic chemistry and energy sources raises intriguing possibilities about alternative forms of life. Future missions to Titan, such as NASA's Dragonfly mission scheduled for launch in 2026, aim to further explore this alien world. These missions will help answer questions about the exact composition of the lakes, their depth variations, and potential seasonal changes. Understanding Titan's methane cycle could also inform our knowledge of Earth's early history and the conditions necessary for life to emerge. By studying this alien yet familiar world, scientists hope to gain a broader perspective on the diversity of planetary environments and the potential for life beyond Earth. Thanks for watching. See you in our next video.